Hey, what's going on, guys? So, what we're going to do today is solve radical equations. Okay, just like everything else for this chapter, we're just going to be dealing with radicals that are square roots. Okay, I mean, basically all these rules apply to third roots, fourth roots, fifth roots, hundredth roots, but for simplicity purposes, we will just deal with square roots. So, what we have here, we have a radical equation because we have the square root of x plus 2 is equal to the number 2. Okay. Now, say we just had x plus 2 equals 2. The thing you always need to do is solve for your variable, solve for the variable x. So we want to get x all alone, and the way that we do that is we use the inverse operations in our equation. So for instance, we have an x plus 2. We need to move this positive 2 to the right side, okay, by subtracting it from both sides of the equation, and we get x equals 0. The reason why we subtract it is because we have an x plus 2. The inverse of adding 2 is subtracting 2, okay, and that's how we get x equals 0. The same goes for when we solve radical equations, except before we can get our x alone, we have to get the radical symbol all alone, okay? So the first thing you want to look at is there any numbers or really anything that is outside of this radical symbol? And the answer is no, okay? Because this plus 2 is underneath, and this 2 is on the other side of the equation, okay? Now, like we talked about in class, the inverse of taking the square root is raising it to the second power, or squaring it, okay? So when you square a square root, the root disappears, or the radical, and you're left with what's ever on the inside. And 2 to the second power is 4, okay? Now, just like in this problem, we're going to use our inverses, or inverse operations, to get x alone. So we subtract 2 from both sides, and x equals 2. And that's that, okay? The whole idea seems, I don't know, not too crazy. But a lot of kids have trouble with it, okay? So here we're going to have 3 times the radical 2x plus 2 equals 15. The first thing we want to ask ourselves, is the radical alone on the left side? Okay? And the answer is no, because we have this 3 here out in front. Before we square anything, get rid of this 3. Okay? It'll make your life easier. So, what's it called? The 3 and the radical, they're being multiplied. So the inverse operation of multiplication is division. Okay? So now we have radical 2x plus 2. Make sure we extend it so it's underneath. Equals 5. Now the radical is isolated on the left side of the equation. So in order to eliminate a radical, or the square root, we must square both sides. So we're left with 2x plus 2 equals 25. Okay? Again, just going along with inverse operations, we need to get this 2x alone, so we subtract 2. And we get 2x equals 23. Divide by 2. Divide by 2. X equals 23 over 2. A lot of you guys don't like fractions. I love them. They're actually pretty cool. They're my friends. So we can just leave it as a fraction as 23 over 2. And that works. Okay. Again, the whole idea of these is we need to isolate the radical all alone. Okay. And this is probably the most complicated one that we're going to be doing, but I don't know. Still, again, it's nothing crazy. So we have 2 times the square root of x plus 2. And it's 2 radical x plus 2 minus 2 equals 12. Okay. Again, we want to get the radical isolated on the left all by itself. Just like when we were solving for the x in this part, we had 2x plus 2 equals 25. We need to get rid of this plus 2 first, okay? So it's kind of like reverse PEMDAS, where PEMDAS you do multiplication, then addition. Since it's reverse, we want to get rid of the addition or subtraction by adding 2, and then get rid of the multiplication or division. So we have x plus 2 equals 14. Divide by 2. Divide by 2. Square root of x plus 2 equals 7. Okay. Now we isolated the square root on the left side, so in order to get rid of a square root, we must square everything, both left and right. When we square radical x plus 2, we're left with x plus 2, and 7 squared is 49. Now we have x plus 2 equals 49, subtract 2, and x equals a grand total of 47. Okay. Again, nothing too crazy. The whole purpose and the whole first thing we need to do is isolate the radical or the square root, third root, whatever root you're taking by itself. So in this problem, we had to add 2 to both sides because that's the inverse operation of subtracting a 2. Then we had to divide by 2 since that's the inverse operation of multiplication. Once you isolate the radical on the one side, you square both left and right sides, since squaring a square root cancels it out. And then we're left with x plus 2 equals 49. To get x isolated all by itself, we subtract 2, and x equals a grand total of 47. Okay, nothing too crazy. This should be fairly simple because I know you guys deal with a lot of solving equations in Algebra 1. So, quick little video. Hope it helped.